Hi, good afternoon. This video is going to be notes on independent versus dependent events for your probability unit. This is page 65 in our notebook. So let's go ahead and get started. The first thing they ask you is, in your own words, tell what independent means to you. So I said something that's in charge. So it's the one that's kind of like the leader, and it's the one that's not affected. And then dependent is the one that is changed by something else. So it's dependent. It gets changed by somebody else. The next thing is simple event. So a simple event is just an event that results in just one outcome. So flipping a coin. A compound event is when you have two or more simple events. So flipping a coin and rolling a dice. Independent events is when the outcome of one event does not become affected by the outcome of the other. So for example, spinning a spinner and picking a card, one does not change the outcome of the other. So to find them, you just do the probability of your first event times the probability of your second event. A dependent event, the outcome of the first event does affect the outcome of the second event. For example, picking a flower and then picking another flower, because when you pick this first flower, you don't replace it. So then when you pick another flower, now you have less flowers and you have a less chance. And how you figure this one out is your probability of A times the probability of B after you've done A. So let's do some examples. So down here, a bag contains 5 pink, 4 orange, 8 yellow, and, gumballs. Find the probability of randomly selecting the green gumballs and then a yellow gumball if the first gumball is replaced. So let's look at this, how many gumballs we have total. So we have 5 plus 3 is 8, plus 4 is 12, plus 8 is 20. So we have 20 total gumballs. So the first one says, find the probability of randomly selecting a green gumball. Well, there's 3 greens, so 3 out of 20. So the probability of G and then Y is equal to 3 out of 20. That's my green. I'm going to replace that gumball. And then the probability of picking a yellow. So yellow is 8. And there's still 20 because I put that other gumball back. And then I can just multiply these two together. I'm going to do a little simplification. And once I do that, I get a total of 3 out of 50. So I have a 3 out of 50 chance of picking a green and then a yellow when I replace the gumball. Here, now I'm not replacing it. So this was an independent. This is going to be a dependent. So 8 cards, numbers 1 through 8 are placed in a bag. 1 card is selected at random and not replaced. So that is affecting the probability of your second event. So another card is randomly selected. Find the probability that both cards are greater than 5. So when talking about that, you're doing probability that it's greater than 5. So your probability of greater than 5, and then greater than 5 again. Well, the first chance, how many cards are bigger than 5? 6, 7, and 8, so that's 3, and there's 3 out of 8. And then the second time, well, now if you pulled a card that was greater than the 5, then now you only have 2 left, and then you only have 7 cards. So then you get to multiply those, and you get, I can do some simplification right here, so I get 3 out of 28. Okay. All right. And then down here, what you need to do, go ahead and decide whether each event is going to be independent or dependent. So Lewis is choosing 1 card from a deck and then choosing a second card without replacing the first. So this would be dependent because it does affect the second event. Adriana picks a flower out of a big bouquet. She doesn't like the one she picked, so she put it back and then picked again. Well, because she put it back, she's not changing the outcome, so it's independent. And then go ahead and do numbers 3, 4, 5, and 6 on your own. All right, now let's open up to the inside where we have a little bit more practice. So this time we're talking about some M&Ms, and we've got different colors. Okay. All right, so a fun-sized bag of M&Ms contains the following 12 candies of different colors. So there are 12. This is yellow, yellow, green, green, red, red, blue, 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 red, blue, and blue. Okay. So find the probability of each event if the M&M candy is replaced. So this is the independent. Over here it says if it's not replaced, so this would be the dependent. So a red candy twice. So how many red candies do I have? 1, 2, 3 out of 12. So 3 out of 12, I'm going to reduce that to 1/4. And then another red candy, because I did replace it, well, that would be another still 1/4. Because it's 3/12. And then when I multiply those, I get 1/16. So I have a 1/16 chance of picking 2 red candies if I put the first red candy back. All right, if I do yellow candy, then a green candy, well, there's 2 yellows out of 12, which is 1/6. There are 2 green out of 12, which is still 1/6. And that gives me a 1 in 36 chance of pulling yellow and then green. And then what's the chance of pulling a blue twice? Well, I have 4 blue out of 12. Well, hold on. 5 blue. I'm sorry. 5 blue. 1, 2, 3, 4, 5. 5 blue out of 12. I can't reduce that fraction, so I'm just going to leave it as 5/12. I replace it, and so it's still 5/12 chance, which is a 25 out of 144 chance that I have to pick that. Green candy followed by blue candy. So green is 2 out of 12, which is 1/6. And then blue was 5/12, which then gives me 5/72. And if we want to look at those percentages to see what they are comparatively that way, we can do that. So 1/16 is about 6%. 1/36 is about 3%. So I'm kind of just rounding these just to a nice whole number. 25 out of 144, about 17%. And then 5 out of 72, about 7%. So the one you have the more likely chance of doing is pulling actually 2 blue candies twice. Over here, we find the probability for each event if it's not replaced. So this is the independent. So red candy twice. Well, there are 2 red candies. So that's 1/6. Okay. But then, wait a minute. I'm sorry. 3 red candies. Sorry. So 3 out of 12 is 1/4. I'm sorry. So 1/4. And then if I take one of those red candies out, because if I pull it, well, then now I only have 2 red candies left, and I have 2 out of 11, because now there's not 12, there's 11. So that gives me 2 over 44, which is 1 over 22. So 1 out of 22 chance of pulling a red candy twice. And so notice the difference between if I do replace it versus if I don't replace it. And I actually do want to look at what that percentage is. So about 5%. So not significantly less, but a little less than what it was over here. Yellow candy, then green candy. So yellow, I have 2 out of 12, which is 1/6. Times, it doesn't affect the yellow, so now I'm doing green. I have 2 green out of 11, because remember, one of those yellows went away. So 2 green out of 11. And that would give me 2 over 66, which is 1 over 33. Okay. Which actually, look at this one. So this actually gets you a better chance of picking it because you're taking one away, giving the green a better chance of being picked. So therefore, you actually have a better chance when it is dependent over here. So it's not always better to be independent. Sometimes it is better to be dependent. All right, your blue candy twice. So what was this? 5 out of 12 the first time. Well, let's take one of those away. So that would be 4 out of 11. Which gives me, if I reduce 12 and 4, that gives me 1 and 3. So that gives me 5 over 33. And I want to do those percentages really quick. So so this is a 3% chance. So really not that much different than this one, but a little bit more. And then 5 out of 33 is a 15% chance right here. Okay. And then the last one, green candy followed by blue candy. So the chance of green is 2 out of 12, which is 1/6. And then the chance of blue is 5 out of 11, which gives me 5 out of 66. And that percentage is 5 out of 66, about 8%. So a little bit better on that one. All right. So what I would like for you to do is go ahead and try these just like you did up here. So make sure that you pay attention where it says Katie picks Airheads, replaces it, and then picks a second one. So these would be independent. I will tell you, some of these are going to be a little different. Like this one says not cherry and then mystery. So let me kind of go over what they mean by not cherry. So if I have 12 Airheads and 4 of them are cherry, that means that 8 of them are not cherry. So it would be 8 out of 12 times, and then mystery is 6 out of 12, which I should have reduced those first. So sorry, let me do that really quick. So divide by 4, you get 2/3 times 1/2. And so you get 1/3. So that's what they mean by not, is you add up the ones that aren't cherries and then you can do it that way. Okay? Down here, Frederick places the 11 cards in the below in a bag. He draws one card, does not replace it, and then draws another card. So this one is dependent. So if he picks an M, doesn't replace it, and then what's the chance of going another M? So the first time is 2 out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 2 out of 11 times, well, that M is gone. So now we have 1 M left out of 10. And then the 2 and 10, that will reduce, so 1 over 55. So that's how you do that one. So be careful with that. And then it says, explain the difference between independent and dependent. So just do a quick little summary. Over here, I do need you to practice more, but some of these are easy. You're just giving me examples of independent versus dependent. This one, just tell me independent or dependent. Don't worry about explaining. Down here, it says, do you find the probability of each event and then classify as independent versus dependent? So that shouldn't take very long. And then over here, they do want you to find the probability, but be careful because it might be independent, it might be dependent. All right, if you have any questions, put it at the bottom of my video or ask tomorrow in class. I know it's a lot of work, but I promise you it won't take as long as you think. Have a great afternoon, and I will see you guys tomorrow.